Okay, in this section here we got a little twist. We call these compound inequalities that we're going to be working at, still under linear inequalities, but these are known as compound inequalities because and or is going to be introduced. Well, let's get started. So I'm going to write out two separate inequalities. So 3x minus 1 is less than 2, and we're going to throw an and in there, and 5x plus 4 is greater than 9. If you hear that chirping in the background, that's some birds. Wish they'd go away. That would drive me crazy. Okay, so we're going to solve these separately here. And so what I'm going to do, just like we've done in the others, I'm going to go ahead and add 1 to both sides. We want to get rid of this 1 here. So we have 3x minus 1 plus 1 is less than 2 plus 1. And so we're going to be left with 3x is less than 3. And of course we're going to multiply both sides by 1/3 because we want to get a 1 here in front of this x. And so we're left with x is less than 1. Okay, well that takes care of this side. Now we need to go over here and work on this side. So we have 5x plus 4. Want to subtract 4. And 9 minus 4. That almost looks like a 7 here, but that's greater than. Okay? And so now we have 5x is greater than, and 9 minus 4 is 5. And then we multiply both sides by 1/5. And so we're left with x is greater than 1. Now let me draw out a graph here so you can see what's going on. X is less than 1, so I'm just going to arbitrarily put 1 right here in the middle and an open circle because we don't include 1. So this means everything less than 1, everything to the left of 1. And this over here means everything to the right of 1. We got this hole here. And means that when I pick a number on the number line, it has to satisfy both this inequality and this inequality. So if I were to choose a number over here on this side and plug it in, it would be good for this guy, but it wouldn't be good for this one over here. So as you can see, there are no numbers, and we have a hole at 1. So there aren't any numbers on the real number line that would make this true and also make this true over here. So the solution set is empty. The solution set is empty, and I can say also this symbol here, which is empty, means empty. The solution set is empty. If you don't understand what all that means, you probably want to go into the sets section and watch some videos on sets. But anyway, there is no solution. Bottom line, there isn't a solution for this compound inequality. Now it's going to be your turn. So we have this compound inequality, and I went ahead and drew a picture down here for you. So you want to try to come up with this down here. Now I'm just going to tell you that it's and, so in other words, a number that you can pick on the number line that's going to satisfy both this inequality and also this inequality here. Well, just by looking at this picture, we can clearly see that there is not going to be a solution. There's not going to be a number we can pick on this number line that's going to make this true and also this true over here. And it's all because of and, right? It must be in this set, and it must satisfy this and this inequality here. But you go ahead, try to work that out, and see if you can come up with this.